Hello, I'm Matthews with the HES for Water team, and this is our MakeOHIO challenge for the 2026 Intel Challenge. The problem that we were given was that semiconductors have a very water-intensive process to be created, and semiconductors can use up to 10 million gallons of water to be fabricated. Most of this water, after it's used, is contaminated, and as far as we know, not most of it gets reused or recycled, and the water treatment is complex and expensive. This issue is important because water is a limited resource, so if we keep using it and leaving contaminated water around, eventually water is going to become even more scarcer than it already is. And it also affects the environment as we're kind of disrupting the local ecosystems as well. There's also an economical side to this as well, where right now the water treatment methods that they have are extremely expensive and high cost. So if we were able to find a lower cost solution, we would save a lot of money. The current system that they use to clean the water for semiconductor fabrication is a 6-step process of pre-treatment, softening, reverse osmosis, deionization, ultraviolet oxidation, and ultrafiltration to create ultra-purified water. And as I stated before, most of this water does not get recycled back as far as we found from our research. So our solution is that we designed the system that can filter the contaminated components of the water from the clean water. And we can also remove any extremities that are found in the contaminated water as it goes through the filter through the means of valves opening up from a clean reservoir to a contaminated reservoir. And ideally, our system should have sensors that can detect the contaminated water as it leaves the filtration system, such that it can properly coordinate the ratios of clean water to recycled water to make sure that the concentration is within proper specs of production. However, with the time restraint that we did have, we weren't able to implement that effectively. The main benefits to our design is that it is extremely cheap to produce, and it would allow for easy mass production in large-scale applications and any type of modification that Intel or another semiconductor fabrication factory might need. So it would be relatively easy to add more sensors to it if they need more data. This is Matthews from the team HES for Water. Thank you for taking your time to listen to our presentation, and thank you.